Welcome to CAC Academy. This is a short, informative video of how to design a D flip-flop counter which produces the following binary sequence: 5, 4, 7, 6, 0, 2, 1, 3. The first step is to create a state transition diagram. As seen on the screen, this is a pictorial representation of how it looks. It starts at 5, and from 5 it goes to 4, from 4 it goes to 7, then from 7 it goes to 6, and so on. Our next step is to create the state table. This comprises of the present state, next state, and data columns. Now we will fill in our column headings. For the present state, let's start with Q2, Q1, and Q0. For our next state, let's start with Q2 plus 1, Q1 plus 1, and then Q0 plus 1. For our data headings, let's do DA, DB, and DC. I went ahead and created a counter, and now we're going to find the binary value of the numbers under the counter heading. So for example, 0 in binary is represented as 3 zeros. Here comes the tricky part, guys, so pay attention. Our next step is to fill out the next state columns. As seen in the sequence, it goes from 5 to 4 and then from 4 to 7. This means we will take the binary value of 4 and place it into the next state column, which is opposite the binary value of 5 in the present state. Now, we're going to place the binary value of 7 into the next state column, which is opposite the binary value of 4 in the present state. This is the binary value of 4 in the present state. We will place the binary value of 7 in the next state. The binary value of 7 is 3 ones. I will show you guys one last time. We're going to place the binary value of 6 into the next state column, opposite the present state columns, which has the binary value of 7. I hope you guys understand, and now I will complete the rest of the next state columns. The next step is to fill out the data columns in the state table, but first I will introduce you guys to the excitation table for the D flip-flop. This says that when the present state is 0 and the next state is 0, then the output would be 0 as well. When the present state is 0 and the next state is 1, then the output will be 1. When the present state is 1 and the next state is 0, then the output will be 0. And when both the present and next state are 1, then the output will be 1. Essentially, we are using the excitation table to fill out the data columns in the state table. So in the first case, we have the present state as 0 and the next state at 0. We're going to look at the excitation table, and here the present state is 0 and the next state is 0. This means that the output will be 0. In the second example, the present state is 0 and the next state is 0. We've just done it, so the output will be, you guessed it, 0. This one is a bit different because the present state is 0 and the next state is 1. So when we're using the excitation table, we're going to see that the output would be 1. I'm going to continue filling this out for the column. So we're just going to repeat the same step, but for DB, we will be using Q1 and Q1 plus 1, and then for DC, we'll be using Q0 and Q0 plus 1. Okay guys, thank you very much for watching the video. This is the final state diagram for the D flip-flop. I hope it was very informative and I hope you guys enjoyed. Thank you. Bye.